Hello and welcome to the Air and Space Live Chat. We've got a great show for you today. I'm Marty Kelsey, one of the hosts of STEM in 30, an Emmy-nominated TV show for middle school students produced by the National Air and Space Museum. And today we're talking all about the solar system. We are joined by Dr. Emily Martin, Dr. Mariah Baker, and Dr. Sharon Wilson Purdy, all who work in the Center for Earth and Planetary Studies at the National Air and Space Museum. And if you didn't know it, the Air and Space Museum explores the solar system. We've got researchers looking at all kinds of things, and I'm going to let these amazing women tell you a little bit about what they study to get us started. So, Mariah, tell us about what you study.
Hi, everyone. My name is Mariah Baker. I'm the newest member of the SEPS team here at the Smithsonian. I've been here for just under a year now. I work on the Mars Science Laboratory Curiosity and InSight missions on Mars, and I study wind-driven transport of sand and dust, or like as we like to call it, aeolian processes. So my research primarily involves looking at images that are taken from Curiosity and InSight, and tracking any movement of sediment on the surface due to wind activity. And so these images can help us understand active atmospheric conditions on Mars, and we can discern things like strength and direction of wind, and how winds vary seasonally and diurnally, all of which is super important, especially if we are lacking direct wind measurements, which unfortunately we often are on Mars. But these images also help us really kind of test our fundamental understanding of the physics behind how wind actually transports material, which is important for not only understanding Mars, but also just understanding landscape evolution on planetary bodies in general, including Earth. And other places like Titan, where we see large dune fields across the surface. And I'll add just one kind of new component to my research since I've arrived at the Smithsonian, has been that I've been able to conduct some terrestrial field work, which is when we go out into arid environments on Earth that are as Mars-like as possible, and study aeolian activity in these environments as a way to understand the observations we're taking on Mars.
Awesome. Well, before we get to everybody else, I want to remind everybody watching, please put your comments and questions down in the comments section. We want to know what questions you have about exploring the solar system, particularly Mars and icy moons that you'll hear about here in just a second. Also, let us know where you're watching from. We'd love to give you a shout out and see what parts of the country and the world are tuning in today. So, Emily, tell us a little bit about what you study.
So I'm really interested in the kinds of processes that create the really weird surfaces that we see in the moons of the outer solar system. I know we'll have some pictures to show you all later, but the moons of Jupiter, the moons of Saturn, Uranus, and Neptune are some of the weirdest places you've seen. And I'm really interested in why they look so weird, and what we can see on the surface and what it can tell us about the interior of these bodies. And why that's really exciting is a lot of these moons of the big gas giants either had or have liquid layers or subsurface oceans underneath their ice shells. And I'm really interested in those kinds of places because those are the kinds of places where we might be able to find life beyond our planet. And the more we can understand our solar system and how water is kind of distributed through it, the more we can sort of look to the solar systems that we're finding outside of ours, and try and understand how possible life might be out there. So I do most of this by looking at the surface of these bodies and trying to figure out what's going on, why these surfaces look so weird, how that happened. And I do it mostly by looking at faults and fractures. So essentially how these moons break and crack at their surfaces. And most of these moons are mostly made out of water ice with a little bit of rock mixed in. So they're kind of like these giant ice cubes that have this sort of like hard, crunchy shell on the outside and this sort of liquid layer in the middle. And so trying to figure out how that liquid layer in the middle helps break up this outer shell is really interesting and kind of helps us understand what's going on in the subsurface. And a little bit like Mariah, one of the cool things about working at the Smithsonian is when you sort of show up, you sort of get to expand your horizons in terms of how you study these things and what you study. And so for me, I've been really recently interested in our moon. So I've spent most of my life, most of my career studying not planets. And so now more recently, I've actually come closer into the inner solar system and I've actually started looking at our moon, which has been really exciting.
Way cool. We've got folks watching from Tampa, Florida, Illinois, Columbus, Ohio, Maryland, Virginia, California, Arizona, Pennsylvania, South Carolina, Indiana, my hometown, Missouri, Germany, and Norway tuning in. Thank you all so much. Be sure to put your questions down in the comments section. We'll get to as many of them as we can today. Sharon, tell us a little bit about what you research.
Hello, everybody. My name is Sharon, and I am a geologist at the Center for Earth and Planetary Studies, and I focus on Mars-related research. I'm involved on the HiRISE camera, which takes pictures on of the surface of Mars, as well as the Mars Science Laboratory rover and the InSight mission, which landed most recently. And my research really focuses on the role of water and how that has changed the surface of Mars over time. So I'm most interested in sort of the younger set of fluvial landforms like alluvial fans, things like deltas, and river valleys that formed more recently than what people originally thought. So that can give us insight into the climate and how Mars evolved as a planet, and a little bit about whether it remained habitable if it ever was. So that's sort of the water angle.
Awesome. Well, you guys are doing some really interesting research, and we've got a bunch of questions coming in. Remember, if you've got a question for these women, please put it down into the comments section. We want to get to as many as we can today. And the first one is from Oliver from Texas, and he wants to know about studying underground on Mars. Do you all study underground, and how do you do that?
I guess I'll answer that. There's a few different instruments that are able to sort of image the surface underneath the ground, and they're on like the Schrad instrument, and so it's a little bit complicated. They can see like layers underneath the ice caps and different materials at depth. But it's not like taking an image. And maybe, Mariah, you want to chat a little bit about insights probing into the actual surface with the.
Yeah. I was going to say we do have folks in our department who use the orbital instruments to kind of penetrate below the surface and see what's below. And one thing in particular that sticks out to me is that we are kind of currently looking for ice underneath the surface that might be able to be used for drilling for future human exploration. So if we can kind of look beneath the surface and find this ice that's hidden, we can possibly access it from the surface. And as Sharon said, InSight was the first mission that went to Mars to really understand the interior of the planet. And so we've got a seismometer there that's measuring Mars quakes and kind of penetrating the depths of the planet that way and trying to figure out the planetary interior and what the core is made of and all of that fun stuff. And then we've also got a heat probe that is currently having some difficulty kind of getting into the surface, which shows some of the kind of mysteries that still lie. We don't really know what's beneath the surface. And so it was kind of a new thing for us to try to do this and to measure the temperature gradient in the subsurface. But we've had some difficulty kind of getting down there. And so we're not sure if there's some rocks in the subsurface that we don't know about or different things, but it's definitely an ongoing research question, kind of trying to probe the interior of the planet.
Nice. And if you want to learn more about the InSight lander and earthquakes and volcanoes here on Earth, you can check out the latest episode of STEM in 30, which was all about earthquakes and volcanoes. And we actually filmed it out near Mount St. Helens in Washington, which was amazing to be able to see that location in person. We've got a question here, and Emily, I'm going to start with you, but I would like each of you to answer this because it's one of our favorite questions that's ever come in. And so what is the most bizarre thing that you have learned since beginning to work at the Smithsonian?
Oh, since beginning at the Smithsonian. Bizarre?
This may have stumped them. This is awesome.
I mean, it's a really fun question, but I think the most, it's really hard because I always talk, one of the fun things about working at the Smithsonian is we get to sort of see all the behind the scenes stuff, and we get to meet all the people who work under the Smithsonian umbrella, which is huge. And so I have a lot of friends and colleagues who work at natural history, and it's one of my favorite places to go, because when you talk about behind the scenes at the Air and Space Museum, like, you know, we don't have drawers that our airplanes fit in because airplanes are too big for that. So natural history is really fun because there's just hallways and hallways and hallways of drawers with their collections. But I think the most, maybe not bizarre, but surprising, is that what's contained inside the buildings on the mall is still just a small fraction of the collections inside the Smithsonian's, or under that sort of Smithsonian's umbrella. So for all the cool wonders that you see on display and that are housed and stored on the mall, there's, I don't know what the percentage is, but there's an enormous amount.
2% is on display.
Well, what about like what's on the mall? It's got to be what, like 15, 20%?
I don't know, but it's amazing. And the piece that always amazes me is how many new species they discover every year out of the collection that have been at Natural History for years and years and years and years. So
it's maybe not bizarre. I will think about it though. And if I come up with a better answer about being bizarre, I'll get back to you.
Awesome. Mariah, how about you?
Yeah, I will say, kind of like Emily was saying, when I first arrived, the advice that I was given was to go over to natural history and get lost. Because if you get lost, people will invite you into their labs and will show you all sorts of cool things. And so I thought that was a very bizarre piece of advice, to get lost in a building. But it's true. There's just so much cool stuff to see, and everybody is so kind of collaborative and inviting that they want to share their research with you. And then I think I'll also add, just kind of as another aside, I think I didn't realize when I first arrived how long so many of these people have been here. I mean, people have been working at the Smithsonian for 40, 50 years, and that's pretty regular. And so it was incredible to see how long people stay around and to learn about some of the mysteries that they've been working on for all of their kind of career, and that are still outstanding questions. And the process that they're going through to kind of decipher things about the solar system that they really have been spending their entire lives on.
Sharon, how about you? Anything bizarre?
I actually started at the Smithsonian at an internship at the Natural History Museum, and back to that place. I think it's a little more bizarre than the Air and Space. And I just was amazed that there was a full laboratory in the Department of Mineral Sciences there, and I was just absolutely blown away by the gem and mineral collection and the meteorite collection. And I just, what makes it on display there is it's almost, the stuff in the drawers is just as good as the things on display. So it's really just a treasure of items. So if you ever have the chance to go back there, you should.
When I first started at the Air and Space Museum, a couple of the guys that I work with said, "Come on," and they took me down into our parking garage, and we went into a little office that was just tucked away in the parking garage, and I had no idea where we were going. And the office was just filled with computer parts and different things that people were working on down there. And they opened the door and we walked out, and the next thing you know, we're in the middle of the missile pit inside the museum.
Oh.
And I had no idea how that was connected to the parking garage. It was one of those really wow experiences of getting to work at the Smithsonian. And somebody asked, so there really is an Indiana Jones warehouse full of artifacts? And I would say absolutely yes.
Yeah.
At the National Air and Space Museum, a lot of our big stuff is on display, but some of it is in a separate building, a couple of separate buildings. And at Natural History, some of it's kind of tucked away, and walking the halls there is definitely a very, very unique experience. We're getting a lot of questions from folks that want to know, when are humans going to go to Mars? And I want to follow that up with, is the work that you all are doing helping with that?
Yeah, so I can try and tackle that or start. I think the sort of there's definitely work going on to put humans on the surface of Mars. And I think every robotic mission that we send to Mars is sort of advancing that in its own way. And particularly the upcoming Mars 2020 rover is definitely going to be making some advances and answering some knowledge gap questions that we need to answer in order to send humans safely to the surface. I think that the current estimates are sort of 2030s area. Don't quote me on that. But I think that that's sort of the the trajectory they're going with. For me, I study atmospheric processes, which are one of the really important things that we need to kind of understand better before we can put humans on the surface of Mars. I'm sure a lot of people out there have seen The Martian, and know, at least from a Hollywood perspective, kind of the risks that might be associated with dust storms. And I won't get into sort of the accuracy of their depiction of it, but there definitely are questions that we need to understand about how wind works on the surface of Mars, the risk posed by dust storms and by other sediment that's being blown by wind. We've often seen, unfortunately, instruments on the surface get damaged by sand that's being blown around. And so all of those risks are important to analyze and are of increased importance when you're sending humans to the surface. It's one thing for instruments to be damaged on the surface, but it's another if there are humans there that are dependent on those instruments. And so I really do think that every mission we're sending is getting us a little bit closer, and Mars 2020 will be answering some of those questions even more, and we'll be actually testing some engineering, some new technology that might help put humans on the surface.
Awesome. And, one of the things that I've heard is that, especially for some of our younger viewers, right now in a school somewhere in the United States is the kid that's going to be the first one to walk on Mars. Mm-hmm. And that just blows me away and makes me so excited about the potential of those students. So if you're watching right now, go down to the comments section and let us know, do you want to be the first one to make that footprint on Mars or not? Let us know why. All right, we've got a lot of questions coming in. We've got folks from New Jersey, Tennessee, New York, North Carolina, Montana, India is tuning in, Georgia, Iowa, Massachusetts, all tuning in. So thank you all for watching. I have a challenge also for our viewers. We have some awesome experts today, but I want you to stump them. Put a question down there that you think is so hard that they can't answer it. And what's going to happen is later it's going to bother them and they're going to go look it up and find that answer, and we'll put it down in the comments. So that's my challenge for all of you today. Okay, somebody wants to know from Harrisonburg, Virginia, and it's for each of you. If you were placing a bet for finding life in our solar system, what icy body or planet would you choose? Where are we going to find life? Emily, what do you think?
Ooh, it's a toss-up actually for me, because I have two icy worlds, two ocean worlds that are near and dear to my heart. Enceladus, which is a tiny little moon of Saturn, and Europa, which is a moon of Jupiter. Now, if it's on Europa, we'll find it first, because we're going back to Europa shortly with the Europa Clipper mission. But Enceladus is really intriguing because it's got this series of jets coming out of the South Pole made up of water particles from the ocean and being ejected out into space. And that's like really easy for a spacecraft to fly by and sort of sample and look for critters in those oceans. So it's going to be a tie for me between Europa and Enceladus, because I can't play favorites amongst my favorites. So my bet's going to be on an ocean world, but our Martians here may have a different idea.
Sharon, what do you think?
I do like the idea of your ocean worlds, Emily. Enceladus is really intriguing because it has both water and presumably heat. So those are two key elements, or so we think. But I'm gonna go with Mars on this one, because we are, I think, a lot closer to just figuring it out. Mars has always been really slow to reveal its secrets, and I think we're right on the verge of cracking it. And that would be wherever we find life next will obviously be like the most exciting discovery of all time. But yeah, so stay tuned.
Cool. Mariah, how about you?
So I'm going to go with something that's a little more out there, and I'm sure the biologists out there will want to strangle me. But I would love to believe. I know that we're often searching for planets that have liquid water, because that's how our biology started. We needed liquid water in order to form. I would love to believe that maybe somewhere like Titan, where there is liquid methane, that some other sort of biology could form in that sort of environment, where they have a hydrologic system and weather and all of those things. It's a very dynamic planet, but it just doesn't have water. So maybe maybe Titan.
Oh,
I would love that to be sort of a new kind of discovery that was unanticipated when we arrive.
well, and luckily the Dragonfly mission's going to help figure that out, and I think Titan's on the list. I'll put Titan's on my list. I mean, who are we kidding? You told me I had to pick one. I thought I was pushing it with two.
And if you want to know more about Titan, check out one of our recent live chats. We had Elizabeth Turtle and a couple other folks from the Titan or from the Dragonfly team join us, and that was a really interesting chat. We've got a bunch of questions coming in wanting to know what's Mars like. So what's the weather like there? And then also the new rover that's getting ready to launch, hopefully at the end of this month. How big is it? And can you guys tell us a little bit about that mission?
Yeah, so I can tackle the weather, and then maybe Sharon can tell us a little bit about the upcoming rover. So Mars is obviously very different than Earth today. It's dry and cold, and so the winds kind of, the temperature fluctuates sort of between, I think you can get up to kind of 70 degrees Fahrenheit on a warm day during in the equator, and then it can go all the way down to like negative 100 Fahrenheit at night because the atmosphere is so thin that it just doesn't retain the heat. So there's kind of really severe temperature fluctuations between day and night. The winds and kind of the weather is something that we're really still trying to kind of put together. There's wind, and there are some sort of clouds that we've been discovering recently, very kind of faint clouds that appear. But the wind, because the atmosphere is like 100 times less dense than it is on Earth, wind speeds really don't feel the same as they would here. So like a 60 mile per hour wind on Mars really feels like sort of a 8 to 10 miles per hour. I'm mixing up all of my my units. If we talk about a 60 mile per hour wind on Mars, it would be about 10 miles per hour here. That's what it would feel like. So really kind of more of a breeze. So that's in terms of sort of what the winds are doing. It definitely feels different, but it's an exciting place, and we're still learning. We really didn't think there would be kind of any winds at all when we first arrived, and it turns out the winds are more active than we thought. So, yeah.
Sharon, tell us about the Mars Perseverance rover and what that mission is going to do for us.
Yeah, so the Mars 2020 Perseverance rover is launching later this month or early August. I think that the window slipped a tiny bit, but August, I think, is the launch, and it'll land in February 2021. It's very similar in size, almost exactly to the Mars Science Laboratory rover that's currently working in Gale Crater on Mars. And this mission, MSL, was designed to characterize habitability and whether there was a habitable environment on Mars, and among other things. But the 2020 Perseverance rover is really going to determine whether or not life ever existed on Mars, at least in the place where we're sending it, which is called Jezero Crater. It's going to characterize the climate and the geology, and it'll have some instruments on board to help prepare for human exploration of the surface. So finding out exactly how unhospitable it really is. And
how excited are you all for this launch and for this mission?
Super excited, yeah. It's going to be amazing.
I'm going to tell a little story about Emily. And Emily, I didn't tell you I was going to tell this. I got a chance to see Emily see the images of Pluto when they first came in. We were doing a program at the museum. And let me tell you, it was like a kid on Christmas morning. Like that image popped up on the screen and she was like, oh, and looking at things and pointing out details. And it was just really cool to see that excitement about these new discoveries. So I'm looking forward to learning about this stuff and seeing what the really smart people like you all learn from all of these new images that come in. Okay, we've got a couple more questions coming in. The Philippines is tuning in, Washington, Mississippi, Colorado, Florida, Wisconsin, and Connecticut. Emily, maybe you can answer this for us. You talked a little bit about the moon. How was the moon formed?
Yeah, so the leading hypothesis, and I'm going to call it a hypothesis because, frankly, until you're like 100% sure, which we always want to think we can get to 100% sure. So the leading hypothesis that we're all feeling pretty confident about at this point is that there was a Mars-sized impactor that struck the Earth And all that debris that kind of came up off of the Earth and sort of intermingled between those two bodies that collided, actually all that debris came out and formed the moon. So that's kind of a short answer to a question where the more scientists continue to explore this question of how did that happen, where did the impactor come from, what was it made out of, how did the dynamics of all of that work, the more we learn about how good that hypothesis really is, and they continue to tweak a lot of the sort of specifications, like little technical details. But from a big picture perspective, it's giant impactor, which is pretty cool.
Now you say a Mars-sized impactor, and this was another question that we had. Mariah, how big is Mars?
Yeah, so Mars is about half the size of Earth in terms of kind of radius. So the radius of Earth is like 6,000 kilometers, and it's about 3,000 kilometers on Mars. So definitely a lot smaller. And there are actually some moons, I think, Emily, correct me if I'm wrong, but that are bigger than Mars. So it's definitely a smaller planet.
I don't know if they're bigger than Mars, but they're almost close, because I think Ganymede and Titan are
Right
about Mercury size.
Okay.
So Mars is still maybe bigger, but there's some really big moons out there.
And Emily, is this the same way that moons form around other planets?
Not necessarily. So Mars's moons, you guys are gonna have to back me up on this. Mars's moons, Phobos and Deimos, are actually captured asteroids, right? Mm-hmm. So you can capture a body and bring it into orbit. The moons are most of the big four big moons around Jupiter, the Galilean satellites is what they're called. And the majority of the moons, the big moons around Saturn, those all formed, we say in situ, which is our fancy language, but really it just means that they all formed in place around those bodies. And they all formed out of that sort of original sort of cloud of stuff that planets get made out of. And there's stuff sort of on the edges of that cloud that don't get incorporated into the formation of those planets, and it often makes a bunch of moons. The process in which all this happens, sometimes early moons collide, they break up, they might form one bigger moon, they might form a bunch of smaller moons. So it's a complicated process, and it's a little bit different in different places for different reasons. One of my favorite moons, Triton, it's the largest moon of Neptune, actually came in from the Kuiper Belt, which is where Pluto lives and all of its moons and a lot of other kinds of really interesting objects. Triton originated there and then got captured by Neptune. And part of the reason we know that it actually didn't form around Neptune is it goes around Neptune backwards, compared to all the other siblings that it inherited when it got captured by Neptune. So moons form in a lot of different ways. And so I think that's part of what makes them so cool and exciting, because they're always these bizarro places. And part of it's because they all came from different places.
Awesome. Well, we've got a lot of people watching. We've got a few minutes left, so put those questions down into the comments section. We have Sam, who is 5. He does not want to go to Mars, but he does want to drive the rover.
Yes.
And Sophia from St. Thomas School in New Jersey is in 3rd grade, and she wants to be the first one on Mars. So Sophia, good luck with that. I'm rooting for you. That would be incredible. And once you do that, come back and talk to us at the museum. So I'm going to start a fight now, if not between you three, at least in the comments. Somebody asked, we were talking about the museum earlier, what is your favorite object in the museum? And can you tell us about that? Sharon, do you have a favorite?
Oh, favorite object. The first thing that came to mind was actually in the Natural History Museum. It's the Martian meteorite called the Lafayette. It's just this beautiful dark mafic rock that has this aerodynamic streamlined feature on it. So anyway, that formed when it came through the atmosphere. But one thing, we have a lot of rocks from Mars, but we don't know where they came from on the surface. One thing I forgot to mention about the 2020 mission, the Perseverance rover, is actually going to collect samples, and then we're sending another mission back to pick them up and bring them back to Earth. So we'll know exactly where these rocks came from, and we can analyze them here on Earth in better labs. So
Awesome. Mariah, what's your favorite object at the museum?
I'm gonna say Sharon actually took my main one that I was gonna say, which is, yeah, I totally couldn't believe that. But and I actually feel like I haven't done enough exploring of the museum since I've arrived. I arrived kind of just before COVID hit, and so I haven't really gotten a chance to explore. And I actually want to do that more. And I will pick out a new favorite now that Sharon stole mine.
Emily, how about you? Do you have a favorite?
I don't. I have a lot of favorites, but when I bring people kind of on sort of short, abbreviated tours around the museum before we really started sort of changing things around for revitalization and the transformation the museum's going under, the non-negotiable, always required thing is the lunar touch rock, which is a little slice of the moon brought home by the Apollo missions. And it's this tiny little jagged slice because all the moon rocks the Smithsonian has live at natural history. And there's this little slice and you can touch it. And so if I were to ever take you around natural history, if I ever took you around the Air and Space Museum, I would make you touch the moon rock. Now, if you went to natural history with me, I would make you touch the Martian meteorite. And then I would say my second favorite object is probably the Sputnik that we have hanging in our milestones gallery. And it's not obviously the Sputnik, but it is a Sputnik. And it's always one of my favorite, not only because it's this really sort of quintessential mid-century modern sort of classic space age look, but a big part of it for me is that it's kind of that sort of really first moment of the sort of planetary science that we all do. Like we all rely on these remote sensing systems and these really complicated robots to help us do our science. So for me, Sputnik is kind of this like foundational object that we have in our collection, and it's also really cool looking.
And I'll actually add, I thought of that as Emily was talking. I think that for me, seeing the mock-up of the Curiosity rover is pretty incredible, because as somebody who works on the rover and has for many years, it's really hard to get a sense of how big this thing is and all of the science it can do. And so when I first came to the museum and was walking around, and I was sort of stunned by how it looked in person. And when it's taking these images of the surface that I look at every day, I kind of take it for granted. But really seeing it in person, it kind of it nails it for you. So I think that's one of my favorites.
And also seeing the progression of the rovers from, how they started the size of a shoebox and got all the way up to, the size of a small car. For me, I always love looking at the blink comparator and thinking about how Clyde Tombaugh had to stare at these images side by side for hours and hours and hours and find one little blip that moved a little bit back and forth to discover Pluto. That just kind of blows me away. Here's a really interesting question that I'd never thought of before. Is there a moon that has a moon?
Emily looked like she had a thought there.
There are some small bodies, asteroids, that have moons. There are Kuiper Belt objects. Is it Makemake has a moon or Haumea has a moon? And because asteroids can become moons, but I don't think there's
I don't know. I know of any, but it doesn't seem like it should be physically impossible. So maybe there is one out there somewhere that we don't know about.
But like Titan, Ganymede, those really big moons don't have any moons. But small things can have moons, if that makes you feel better.
That's a great question. I thank you for submitting that one.
That one up.
Okay, we've got somebody that wants to know if, and this one I think is for Sharon and Mariah, do you study Olympus Mons, and could it erupt? And if it does, what's going to happen to astronauts that may be there if it erupts?
Mariah, I don't study volcanoes on any planet, but the Olympus Mons is the largest volcano in our solar system, so it is a pretty prominent feature on Mars, but it hasn't been active in a very long time. because Mars is so much smaller than the Earth, it cooled faster. And so we don't think it's had any like active heat in a while. So no active volcanoes on Mars. So it shouldn't be a problem. They can run up and down it if they want.
All right, we've got a bunch of questions that are coming in about the atmosphere on Mars and, you know, how we compare that to Earth, and is that analogous? Are we going to be able to say that, you know, if we don't change things, Earth is going to look like Mars sometime? Like, what are those comparisons there?
Yeah, I mean, it's definitely different, and we know that that Mars's atmosphere used to be much denser, much more similar to what we have on Earth. Whether or not Earth will eventually look like Mars one day, I think we'll have to wait around and see. Hopefully not in our lifetimes, but yeah, the atmosphere on Mars has gotten stripped away in different ways over its history, and so what's remnant there is very thin carbon dioxide atmosphere. So not hospitable to humans and not really breathable. But I will say that one of the interesting in my opinion, one of the most interesting things that the Mars 2020 rover is going to do is it has this instrument on it that's going to be intaking carbon dioxide from the atmosphere and is going to try to produce oxygen from it that can be used by humans on the surface. And so that's one of those tech experiments that's super interesting, and that's basically trying to utilize what we have there on Mars and the atmospheric conditions there and turn them into something that may be more hospitable to humans.
Interesting. All right, we've got a question, and Mariah, you touched on this a little bit earlier. You know, life as we know it is carbon-based, but if it could develop in other ways, how would we recognize that, or would we be able to with the instruments that we use to study these planets? Who wants to take that one?
Emily, do you want to take that one?
So because I've been really steeped in the ocean world community for a long time, there's a lot of colleagues of mine, even though not a biologist, not an astrobiologist, not a chemist, not a biochemist, keep all of those things in mind when I answer this, but there's a lot of conversation right now in the astrobiology community about just this. Mm-hmm. How do you define life? How do you detect it? And it always comes back to that sort of extraordinary claims require extraordinary evidence. If you're going to say you found life, you have to be really sure. And it comes back to sort of Mariah's point of what if we're not looking at carbon-based life? And those are the kinds of conversations that astrobiologists are having when they're talking about the kinds of instrumentation to design, to put on spacecraft to either go into oceans or to be sensing the kinds of materials that you find on the surface, like Martian sediment. So I know that's not a really satisfying answer, other than like that's a question that's being addressed in the astrobiological community right now, because that is the question. And I think I would really encourage you to go learn more about the Dragonfly mission and look at some of the information that's on that website, because they do a really wonderful job about talking about the sort of open questions in prebiotic chemistry and the kinds of ways that the Dragonfly mission is going to try and answer some of those questions. And Titan's the place that Mariah was talking about, where there's a water ice shell that's sort of the crust, but on top of that is where you have all these methane and ethane and there's carbon in there, but it's not, you wouldn't necessarily expect to find the same sort of carbon-based life necessarily. And so I would really encourage our viewers to go look at the Dragonfly mission, because I think that's going to be really valuable, and to go check out the program you did with Elizabeth Turtle, who's the principal investigator of that mission.
Awesome. All right, so we've got time for one more question. I want to ask each one of you, and we've gotten it from a couple of different folks, including a 10-year-old. They want to know about your experience getting into STEM fields and what recommendations you have for people that want to follow your career path. Sharon, you want to start us?
Sure. So I just really enjoyed math and science growing up, and it wasn't until I went to college and took my first geology course that I really realized that's where it all came together for me. It was like the perfect application. And I studied igneous petrology at Middlebury College, and then I I moved into sort of the Martian meteorite realm, and then went on to get a master's and a PhD at the University of Virginia. So as a youngster, I think the best advice is to keep studying, work hard, and don't neglect your writing skills too, because being able to like do science is one thing, but writing it up and making other people be able to understand it is also so critical to the success of your research. So,
Mariah, how about you?
Yeah, so like Sharon, I think growing up, I was always interested in sort of the math and sciences. Chemistry was my favorite class in high school. And so I knew kind of when I went off to college that I wanted to sort of pursue something in the sciences, wasn't really sure what. Ended up getting a degree in astrophysics, which I loved because it was sort of part of the space sciences. But I really felt it was a little too intangible for me. And so I really wanted to kind of get my hands a little dirtier. And so planetary science is this nice kind of mixture between astronomy and geology, and is a little bit more tangible, and you're not kind of studying specks of light that are hundreds of thousands of light years away. But so for me, I think it was a good fit. And I would say for anybody kind of interested in space sciences or planetary science, there's so many different things that you can do in this field. I mean, on a day-to-day basis, we work with, geologists, geochemists, there's astrobiologists, there's geologists, there's, I mean, a whole range of people. And so I think you find what excites you, and hopefully that will kind of steer you in the right direction. And I would also say, reach out to people. I think that that's one of the biggest things that I have found useful in kind of finding my way, is just reach out to people, ask them what they do, ask them if you can get involved. People in this field are really inclusive and like to get other people excited about what's going on in space exploration. And so never hesitate to just shoot someone an email and say, I'm interested in this. Can we talk? Just go for it. And hopefully you'll find your way.
Awesome. Emily, how about you?
I think I have a little bit of a different experience in that I actually I had really great math and science in high school, but I also had really great literature and all other kinds of experiences. So I actually didn't know that, STEM wasn't a thing when we were, I feel like, going through this process, right? So I ended up really thinking that a liberal arts education was what I was looking for in my college years, because I wasn't ready to commit to sort of one side or the other. And really sort of by chance, I ended up kind of getting absorbed into the physics department. So I have a BA in physics because it was a liberal arts college. And the department was really about the people. And so for me, my experiences have been really sort of kind of, Mariah touched upon this. My experiences have been really shaped by the people that I've met sort of along this journey. And I think it's really important to keep in mind that you don't necessarily need to know what the end point looks like or what the end goal looks like. It's really about being curious and asking questions and talking to people and meeting people and networking with those people and sort of moving through the opportunities that you create yourself and kind of moving from one door to the next, not always knowing sort of what your end point looks like. And so for me, I certainly didn't leave college expecting to get a PhD to study planetary science. I kind of was like, I kind of was working my way through okay, I'm getting ready to leave college. What's my next step going to look like? And for me, it turned out that graduate school was the best way to go. But I was like, I want to study icy moons, and I want to study the surfaces, and I want to study the things. So it really kind of came into this huge team effort to help me narrow down and find the program that was going to really work for me. So I think my biggest piece of advice is to not necessarily, sometimes it's helpful, but to not necessarily to put your sights on sort of the end goal, but to sort of take into consideration all those steps and all those opportunities that those steps can provide you sort of along this way, and really focusing on the things that you're curious about and constantly asking questions about them.
Awesome. Well, I get excited learning about this stuff, just talking to you all. If you've watched today, be sure to go down into the comments section and let us know, what are you excited about learning about? We'd love to know those different topics. Mariah, Sharon, and Emily, thank you all so much for joining us today. We want to remind everybody that next week we're going to be talking about space junk with Mariba Jha, and that's part of the Earth Optimism Summit. And the following week, we'll be back into the solar system talking about Mars and the launch of the Perseverance rover. I know we're going to have Kobe Boykins, one of the guys that works on rovers, as well as one of our curators on there, and maybe another guest as well. So we're looking forward to those chats. And then also, we want to share with you Launch a Conversation. The National Air and Space Museum is launching a conversation. We have seen the recent SpaceX and NASA launches to the International Space Station, and there's an upcoming launch of the NASA Perseverance rover to Mars. Did you watch the SpaceX launch in May? Do you plan to watch the Mars rover launch later this summer? We are witnessing these launches as the country struggles through the coronavirus pandemic and nationwide protests over racial inequality. But previous launches have happened during contentious times as well. We invite you to launch a conversation with your friends and family about previous launches and what was going on during those times. We encourage kids to ask your parents and parents to ask kids, what launches do you remember? What do you recall about those times and what was going on in the world around you? What were the big concerns of those times and what were the social problems? What was going on in your life at that time? And if you follow the link on the screen, and we're going to put it down in the comments, it'll take you to some resources for you to launch your own conversation. And we want you to share with us what you discover. You can share these on any of the National Air and Space Museum social media channels or on STEM and 30's social media channels. And we cannot wait to see what you discover. So Mariah, Sharon, Emily, thank you all so much for joining us. Thanks everybody for watching, and we hope to see you again next time.
Thanks.
Bye.